So get this, the average knowledge worker spends almost 2.5 hours a day just searching for information. 2.5 hours! That's like a third of their workday gone. Poof! Vanished into the digital ether.
Wow, okay, I knew it was bad, but that's staggering. You're talking about information overload on steroids, right? It's not just finding the information, it's sifting through the noise.
Exactly. And that's where Agentic AI comes in. It's not just about building smarter search engines, it's about creating intelligent agents that can proactively find, filter, and even act on information on our behalf. Think of it as going from having a personal assistant who can answer your questions to having an entire autonomous team that anticipates your needs before you even articulate them.
Okay, I'm with you on the promise, but the jump from assistant to autonomous team feels ambitious. What breaks down if we don't move in this direction? What's the real cost of sticking with current AI approaches?
Well, think about the increasing complexity of modern software systems. We're building these massively distributed, interconnected networks, and humans simply can't keep track of all the moving parts. The cost of not adopting agentic AI is basically slower innovation, more errors, and ultimately a massive competitive disadvantage. Imagine Netflix trying to personalize recommendations for hundreds of millions of users without intelligent agents constantly learning and adapting to their preferences. They'd be stuck with generic suggestions and lose subscribers left and right.
Fair point. Netflix's recommendation engine is a great example of something that's already pretty sophisticated but could definitely benefit from more autonomy. So let's dive into the core of agentic AI. What are the key technologies that make it tick? I imagine it's more than just large language models.
Oh, absolutely. LLMs are a crucial piece of the puzzle, but they're just the foundation. Think of LLMs as the brains of the agent, capable of understanding and generating human-like text. But you also need muscles, the ability to interact with the real world, access APIs, and execute actions. And that's where things like reinforcement learning, planning algorithms, and knowledge graphs come into play.
Okay, break that down a bit. Reinforcement learning, I understand, training the agent through rewards and punishments. But what role do planning algorithms and knowledge graphs play?
Right, so planning algorithms are what allow the agent to think strategically and break down complex tasks into smaller, more manageable steps. Imagine you want an agent to book you a flight and hotel for a conference. It needs to not only find the best deals, but also consider your preferences, travel dates, and budget. Planning algorithms help it create a roadmap to achieve that goal. Knowledge graphs, on the other hand, provide the agent with a structured representation of the world. They allow it to understand relationships between different entities and reason about information in a more sophisticated way. Think of it as the agent's internal encyclopedia.
That makes sense. So LLMs provide the language understanding, reinforcement learning helps with adaptation, planning algorithms enable strategic thinking, and knowledge graphs provide the context. Can you give me a concrete example of how these technologies are being used together in a real-world application?
Sure. Look at what OpenAI is doing with their Assistants API. It allows developers to build custom AI assistants that can perform a wide range of tasks, from writing emails to generating code. It's basically a toolkit for building your own agentic AI system. And the really cool part, you can give these assistants access to your own data and tools, allowing them to automate tasks that are specific to your business.
Okay, that's a good example of a platform, but what about a company building something from the ground up? How are they architecting these systems? Let's look at autonomous driving. Companies like Waymo and Tesla are essentially building agentic AI systems on wheels. They're using computer vision to perceive the environment, planning algorithms to navigate roads, and reinforcement learning to improve their driving skills over time. The architecture is incredibly complex, involving multiple layers of abstraction and a constant feedback loop between perception, planning, and action.
So lots of sensors, lots of data, and a highly iterative development process. What about the muscles you mentioned earlier, the ability to interact with the real world? How do these agents actually do things?
That's where APIs come in. Agentic AI systems need to be able to interact with external services and data sources through APIs. Think of it as giving the agent a set of tools that it can use to accomplish its goals. For example, an agent that's designed to manage your finances might need to interact with your bank's API to access your account information and make transactions. Or an agent that's designed to automate your marketing campaigns might need to interact with your email marketing platform's API to send out emails and track results.
So API security becomes paramount. You're essentially giving an AI agent access to sensitive data and the ability to perform actions on your behalf. What are the key security considerations when building agentic AI systems?
You hit the nail on the head. Security is a huge concern. You need to implement robust authentication and authorization mechanisms to ensure that only authorized agents can access your APIs. You also need to carefully monitor the agent's activity to detect and prevent malicious behavior. And you need to have a clear understanding of the agent's capabilities and limitations to avoid unintended consequences. It's not just about securing the APIs themselves, but also securing the agent's internal state and preventing it from being compromised.
This feels like a whole new layer of complexity compared to traditional software development. We're not just building applications, we're building autonomous entities that can interact with the world in unpredictable ways. What are some of the other challenges that lie ahead?
One of the biggest challenges is explainability. How do you understand why an agent made a particular decision? This is especially important in high-stakes situations, like healthcare or finance, where you need to be able to justify the agent's actions. Another challenge is bias. Agentic AI systems are trained on data, and if that data is biased, the agent will likely exhibit the same biases. This can lead to unfair or discriminatory outcomes. And then there's the ethical question of autonomy. How much autonomy should we give these agents? At what point do they become too powerful or too independent?
Okay, explainability, bias, and ethical considerations. Those are all huge challenges. But let's say we can overcome those hurdles. What's the ultimate vision for agentic AI? What does the future look like?
The ultimate vision is a world where AI agents are seamlessly integrated into our lives, helping us automate tasks, solve problems, and make better decisions. Imagine a world where your personal AI assistant manages your schedule, pays your bills, and even anticipates your needs before you even realize them. Or a world where autonomous networks of AI agents are managing complex systems like the power grid or the transportation network, optimizing efficiency and preventing failures. Wow, that sounds both incredibly exciting and a little bit terrifying. It's a future where the line between human and machine becomes increasingly blurred.
Exactly. And here's where it gets really interesting. Most engineers think about agentic AI as just automating existing tasks, but the real paradigm shift is when agents start creating new tasks and opportunities that we haven't even thought of yet. Think of it like this. Before the internet, nobody imagined things like social media or online streaming. Agentic AI has the potential to unlock a similar level of innovation, creating entirely new industries and ways of working.
Okay, that's a compelling point. It's not just about automating the mundane, it's about augmenting our own intelligence and creativity. But wait, doesn't that mean we need to rethink our entire architecture to software? We're not just building static applications anymore. We're building dynamic, evolving ecosystems of intelligent agents.
Precisely. We need to move away from monolithic architectures and embrace more modular, decentralized designs. Think of it like microservices on steroids. Each agent should be a self-contained unit with its own set of responsibilities and its own API. This allows for greater flexibility, scalability, and resilience.
So, what are the practical takeaways for a software engineer listening to this right now? What should they be doing differently after listening to this episode?
First, start experimenting with LLMs and other AI tools. Get familiar with the building blocks of agentic AI. There are tons of open-source libraries and APIs that you can use to build your own AI agent. Second, think about how you can break down complex tasks into smaller, more manageable steps. This is essential for building effective planning algorithms. And third, embrace a more modular, decentralized architecture. This will make your systems more flexible, scalable, and resilient.
Okay, so experiment, decompose, and decentralize. That's a good starting point. And I'd add one more thing. Think critically about the ethical implications of your work. Agentic AI has the potential to do a lot of good, but it also has the potential to do a lot of harm. It's our responsibility as engineers to ensure that we're building these systems in a responsible and ethical way.
Absolutely. Remember, with great power comes great responsibility. Or, to put it another way, don't build Skynet.